All right, this is number 9. Okay, I'm going to do a rewrite so it's easier to see. Sine x times cosine of x to the negative 2 power. All right, so what is so you can see that cosine x is living inside of another function, an exponent of negative 2. So what is the derivative of cosine x? Well, the derivative of cosine x is negative sine x. So I'm just missing a negative sign. Compensate for that negative sign with a negative there. Now, all I can do, or all I need to do, is do the power rule on this. So that's going to be cosine x, add 1 to the exponent, divide by the exponent. Okay, so those two negatives, plus c, it's plus c because this is a indefinite integral. And that's just going to be, the negatives cancel, you get cosine x to the negative 1 plus c. So that's 1 over cosine x plus c. That's it. All right. Okay. All right, there was some controversy on number 10. Is that an x cube or is that a cube root? Well, to make things easier, we can just make that a cube root. All right. So this is equivalent to integral of 5x times 3x squared minus 1 to the 1/3 power. Okay. If that's x cubed, it makes the problem really hard. In fact, yeah, it's just so hard I don't want to do it. All right, but here, what is the derivative of the inside part of this function? What is the derivative of 3x squared minus 1? Well, the derivative is 6x. So I have this pesky 5 there that I can just shove out. So it's going to be 5 integral x 3x squared minus 1 to the 1/3. So I need a 6 here because the derivative is 6x. I'm sorry, the derivative of 3x squared minus 1 is 6. So I'm going to put a 6 there, compensate for that 6 by dividing by 6 out there. All right, now we're going to go, what are we going to do? So it's 5, 6, and I can just do power rule on this 1/3. So that's going to be 3x squared minus 1, add 1 to the exponent, which should be 4/3, divide by the exponent, plus c. Clean that up a little bit. Not much you can do here. So it's 5, 6 times 3/4. 3x squared minus 1. So all I did was rewrite it as its reciprocal, and that's going to reduce some. So 3 goes into 6 twice, so that's going to be 5/8. 3x squared minus 1 to the 4/3 plus c, and that's the answer to number 10. And no, you don't have to do anything else with that. All right. Sorry about that beeping noise. We are now on number 11. All right, what do we got here? So this is the graph of f. This is the graph of f. Which of the following could be the graph of g? This is the graph of f? Wow, okay. And it's starting at 2. So if 2 is over here, whoa, this is really bad. Okay, so if 2 can be somewhere, it could be here, it could be here, it could be here. So it's kind of ambiguous, all right? Let's see. Let's pretend that it's here. 2 is here. So from here to here, even though it's negative, it can be positive, okay? Or if this is 2, let's pretend that's 2. If that's 2, then this, even though it's negative, it can be positive, okay? All right? Okay, whatever. All right. And then after that, it's positive for sure. This one says it's a constant the whole time. Can g be a constant? Can g be a constant? What is f prime of x? F prime of x would be g of x. What is the derivative of f here? If this is the graph of f, then f prime of x is just the slope of this line, which would be a constant. So in fact, A is the answer. So in fact, I overthought it with this whole 2 idea, right? So if this is f of x equals that mess, if I take the derivative, then the derivative is this. And this is the graph of f. If this is the graph of f, and we take the derivative of f, right, it's the slope of this line. Well, the slope of a line is constant. So that's it, right? And it's not b because this is not a negative slope, right? This is a positive slope. So the answer is A. Let's go on to number 12. 12. All right, again, you're taking the derivative of an integral here. So when I take a derivative of an integral, I just plug it in. So it's 1 plus square root of x squared, right? And then take the derivative of square root of x, which would be 1 half x to the negative 1 half. Okay, now let's look at that. So I want to write this a little bigger so it's easier to see. Square root of x squared, right? The square root of x squared just becomes x. And I'm going to multiply that by 1 over 2 root x. Okay? And can you see which one this is going to be? So I have a 1 over 2 root x here and then 1 plus x. So the answer is A. All right? Let's go on to 13. Ruth rode her bicycle on a straight trail. Okay. I don't think you're going to be able to see this whole thing, are you? Maybe? Yes? No? I don't know. All right. Using correct units, interpret the meaning of 0 to 1.2 and approximate the value using 3 trapezoid. All right. So it's going from 0 to 1.2. So be careful, right? The question is only asking for this part, right? From 0 to 1.2. It's not asking for the whole thing. So when we integrate that using trapezoid, it's going to be 1 half 0.4 times 0 plus 11.8. So this is the area of the first trapezoid, right? The distance between my t values is 0.4. The 1 half is always part of the trapezoid formula. The 2 bases are 0 and 11.8. Excuse me. And I'm doing the next one. Well, it looks like they're all 0.4 units apart. All right. And the next pair is 11.8 and 9.5. And that's 9.5 or 17.2. All right. So you do notice that there's a half 0.4 for each of them, and half of 0.4 is 0.2. So I can just write 0.2 times 0 plus 11.8 plus 11.8 plus 9.5 plus 9.5 plus 17.2. And I'll let you work that out. If you left this on an AP test, I'm giving you full credit. An AP will give you full credit too. Like, you don't have to work that out. All right, moving on. 14. Regions A, B, and C in the figure above are bounded by the graph of the function. The region A is for... So, even though they say area B is 16, technically it's negative because it's below the x-axis, okay? But because they're describing it as just plain old area, they're giving you the positive value. But B has a negative value. All right. And it says, what is the average value of the interval from 0 to 8? So you're going to do positive 14 plus a negative 16 plus 50. That's going to be what? Negative 2. So that's equal to 48. It has a length of 8, so you divide by 8, and you get 6. So the answer is A. 15. So that would have been a non-calculator question. All right, 15. Okay, what does it say? Let f be a function such that happens. Which of the following must be true? So notice they're changing variables. They're changing variables. And that's equals 10. Really? Right. They're changing variables. So that means t equals 2x. So that's like saying u equals 2x. So dt would equal 2dx, right? The dx, I have to solve that for dx. So that's going to be 1/2 dt equals dx. So let's do some substitution. Okay, so that's going to be f of t. I'm replacing the dx as 1/2 dt. So it's 1/2 dt. Now the intervals change. If it's 6, right? That's x equals 6. So that means x equals 12 to 24. So 12 to 24. Okay. Now the original was equal to 10. But notice none of these have a half on there. So that means when I rewrite this, instead of saying it's equal to 10, I want to say it's equal to 20, right? Because I'll bring the half over, right? I'm going to multiply by 2, so I get 20. So that one is choice B. That was clever. And the last example, and they give you the u substitution this time, right? U equals sine 2x. U equals sine 2x, so let's do that substitution. U equals sine 2x. So du, what's the derivative of sine? It's cosine. So it's cosine 2x, but the derivative, chain rule, you gotta multiply by 2. All right, so that means this is missing a 2. So I'm going to just say 1/2 du equals cosine 2x dx. So I can replace the cosine 2x dx with 1/2 du. So let's do the substitution. So I'm not going to write sine to the 5th, I'm going to write u to the 5th. So it's u to the 5th, and I'm replacing cosine 2x dx, cosine 2x dx with 1/2 du. Now, this is x equals pi over 6 to x equals pi over 2, but I'm doing this substitution of u. So let's do that down here. If x equals pi over 6, then it's sine of 2 times pi over 6, which is sine of pi over 3, which is square root of 3 over 2. So I'll put square root of 3 over 2 down there. All right, and then if x equals pi over 2, then that's u equals sine of 2 times pi over 2, which is the sine of pi, which is 0. So it's going up to 0. All right, so let's clean this up. I'm going to move the 1/2 outside. So square root of 3 over 2 to 0, and it's u to the 5th du. And let's look for square root of 3 to 0. There it is. And the answer is D. Okay, and that's the end of the video. And that got really long. I think I was enjoying myself. Okay, bye-bye.